This video will discuss Coulomb's law. This video's objective is that students will be able to recite the properties of Coulomb's law. As always, you'll need some paper and something to write with, and let's go ahead and get started. So first, let's talk about what Coulomb's law actually is. So if you take a balloon and rub it on your shirt, it becomes charged by friction, gaining electrons. And if you were to do this to two balloons, so you have these two insulators with this charge on them from rubbing against the shirt, what would happen if they were brought near each other? Would they repel, attract, do nothing? They would indeed repel. They would have the same charge, so they would definitely repel each other. And since it's got to be some kind of force that's separating them. And Coulomb's law is the mathematical way to determine how much force is pushing them apart. The things that will affect it are the amount of charge on each object and how far apart they are. And just like Newton's law of gravitation, the closer they are together, the more force there will be between them. And if there's more charge on each one, then there'll be more force. And if you were to increase the distance, then the force would decrease. So here's the equation. The electrostatic force, that's what that E stands for, equals K times Q1 times Q2 divided by R squared. And the Q's stand for the charges, measured in coulombs, which the letter for which is C. That R in the denominator is the distance, not the radius, the distance between the charges, measured in meters. Fe is the electrostatic force, and like all forces, it's measured in newtons. And that K in the front there is a constant and has the same value no matter what problem you're doing. And its value is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. So just like Newton's law of gravitation, this one has a constant, and it always goes in the equation. And that constant's written on the equation sheet, so you don't have to memorize it, but you do have to remember to plug it in. The other thing about this equation is it has these absolute value lines on either side of the force and on either side of the charges. So you're finding the magnitude of the force, not the direction. And for the sake of argument, if both of these charges are positive, the force would be a repelling force, because like charges repel. If Q1 were positive and Q2 were negative, then they would attract. So it would be an attractive force. Time for a question. So by what factor would the electrostatic force between two charges change if the distance between them was quadrupled? So 4 times as much distance. And what would happen to the electrostatic force? If you said 1/16th, that's totally correct. That would be true since Coulomb's law is an inverse square law, just like Newton's law of gravitation. They both have distance squared in the denominator of the equation, and this means that as the distance increases, the force would decrease by the square of whatever factor it was increased by. So a 4 times increase in distance would be a 1/4 squared, or 1/16 factor of force. So it'd be 16 times less force if it's 4 times further away. And that about wraps it up for this video. Remember to take the Edmodo quiz and to bring your notes with you to class next time so you can use them on the quiz. And thanks for watching.